So this is our last section of Unit 6, and we are talking about linear programming. This is also going to be your project that you work on in this unit, and it will be a project that you start in class and then finish over the February break, and it will be due by midnight on Friday, February 26th. So it's going to be an electronic project for the most part, and then you will have it done on a Google Doc and drop that link to me on a Google form that I send you. That's already in your school loop. Okay, so what linear programming is really used for, and this is absolutely used for in real business, is for those kind of business decisions when they are trying to decide what to make, what not to make, how to maximize their revenue or minimize their costs, because the two go hand in hand. So as your notes for this section, we're actually going to do kind of part of an example problem. So first of all, finding minimum value. So suppose you want to buy some MP3s and some CDs. You can afford as many as 10 MP3s or 7 CDs. You want at least 4 CDs and at least 10 hours of recorded music. Each tape holds about 45 minutes of music, and each CD holds about an hour. So write a system of inequalities to model the problem. So the first thing is I'm going to use, again, when I do word problems, I tend to use variables that make sense to me. So for our CDs, I'm going to use C, and for my MP3s, I'm going to use M. Oops. That doesn't want to erase for me. CDs. And I'm going to use M for MP3s. Okay? So let's think about the limitations that I have. And there's a reason that I circled these things. So you want at least 4 CDs and at least 10 hours of recorded music, meaning it can be more than 10 hours, but it's got to be at least 10 hours. Okay? So it says you can afford as many as 10 MP3 players or 7 CDs. You want at least 4 CDs. So let's just start with our CDs. So our CDs, and I'm going to use my own variables, have to be at least 4, which means they can be greater than or equal to 4. You can afford as many as 10 MP3s or CDs, which means that you can't afford any more than 7 CDs. So however many CDs you buy needs to be between 4 and 7. You can either buy 4, 5, 6, or 7. Those are the amounts that you can buy, because they want you to buy at least 4, no more than 7. Okay? Then you know that your MP3s hold about 45 minutes of music, and your CDs each hold about an hour of music. And we want at least 10 hours of recorded music. So what I'm going to do first is I'm going to change everything into minutes. And the reason I'm doing that is because I've got 45 minutes. So if I change that into hours, I would have 3/4 of an hour. Of course, we don't want to deal with fractions, so I'm not going to deal with fractions. So we call that our objective function. And we're going to have some definitions at the bottom, so you don't need to write them in right now. But I know that if I for every MP3 I have 45 minutes of music for every MP3. And every CD I have holds about an hour, which is 60 minutes of music for every CD. I want that to be at least 10 hours of music. So that can be greater than that total between the two. This total can be greater than 10 hours, but it's got to be at least 10 hours. So that means it can be greater than or equal to 10 hours, which is 600 minutes. Okay? So once you have those, and you're always dealing with inequalities with linear programming, always, always. At least than, more than, no more than, all of those terms have to do with inequalities. So now I'm going to graph those. And the first thing I'm going to need to do is label my axes. And typically you're only going to deal in the first quadrant here. And the reason for that is you can't buy negative CDs. You can't have negative MP3s. So nothing over here really is going to apply. You're only going to deal in that first quadrant. Okay, so let's graph our CD ranges first. So I'm going to go ahead and label my axes, and I'm going to make the x-axis my CDs and the y-axis my MP3s. You could certainly switch it around. It doesn't really matter as long as you keep it consistent. Okay, so I know that my CDs have to be at least 4 and less than 7. So that means they have to be at least 4, and that's going to be a solid line, and less than 7. And that's going to be everything within this range. Okay? So there's my range. Oh, do I really need this down here? No, not really, because I can't have negative CDs, so, or negative MP3s. That's my range right there. Okay, then to graph the other, now you could certainly change that around to slope-intercept form if you recognize that this is your y value because it's on the y-axis. I prefer to use my intercepts, so that's what I'm going to do. I think it's easier. So let's set each of those equal to 600. So if you used no CDs, so this value was 0. I bought no CDs, and I only used MP3s. How many MP3s would it take me to get 600 minutes of music? So that would be 45M is greater than or equal to 600. I would divide by 45, and that would give me M is greater than or equal to, I don't know what 600 divided by 45 is. Hang on one second, because I don't think that's even, which is okay. 600 divided by 45 is 13.33. Well, we can't really buy a third of a CD, but that's okay. So we will, for graphing purposes, we're going to use that. So that's actually going to be up here somewhere. And then we'll do the same thing for the CDs. And if I only use CDs, they give me 60 minutes each. And I need 600 minutes total. So the number of CDs I would need to use would be 10. So that's going to be right here. And I'm actually going to change the colors of that line. And then because it's greater than or equal to, it's going to be that area right there. The other constraints that I have are going to be that it's got to be within this first quadrant, because like we said, we can't have we can't have negative CDs or negative MP3s. So for this line here that I did for my CDs and my MP3s, it would highlight right over here. Okay? So the only area think of our systems of inequalities that we did earlier in the week. The only area where those overlap is this region right here. So those are all of my possibilities, is this area right there. Okay? So we're going to go down here and do some definitions, and I'm actually going to probably type these in so it's a little bit cleaner for you. Let me get it down where I want it to be. So linear programming, get this stretched out for you. Okay. Come on. So the definition of linear programming is a mathematical technique talking about. Okay. So when we graph our linear program, we can come up with a range of solutions, because there's not just one option in business. You've got lots of different options usually. So I'm just going to write this in, range of solutions. That satisfies all of the constraints, so all of your limitations, that satisfy all the outcomes. So given the limitations that you have, can you still get what you want? Given the number of CDs I have to buy, can I still get the number of minutes that I want? Okay? The vertex principle says that if there is a maximum or a minimum, or a minimum value of the linear objective function, it occurs at one or more points of that solution set. So what it's saying really is if this is your range of solutions, your maximum or minimum, depending on what you're looking for, has got to be within that range somewhere. Anything out of the range is not even an option because it's outside of the limitations or the constraints that we have. Okay? All right, good. So let's scoot up to our example at the bottom. Everybody got those? Good. Given the following constraints, what values of x and y maximize p, and this is supposed to be for the objective function, not from, form, for, the objective function p equals 3x plus 2y. So the first thing that we would do, and I'm just going to do a quick sketch of a graph. So we've got y is greater than or equal to 3 halves x minus 3, y is less than or equal to negative x plus 7, y is greater than or equal to 0, and y is greater than or, x is greater than or equal to 0, and y is greater than or equal to 0. So, let's see. I am chord. Hopefully it's going to do that. Let's see what happens there. Okay, and then now we're going to evaluate each of these. So when it says evaluate, we're going to take that objective function that we have right here, this p equals 3x plus 2y. So p equals 3x plus 2y. But now I've got 4 different points that I'm going to check for that and see which one gives us the biggest number. In this case, we're looking to maximize, not minimize. So if we're looking for the biggest, we're maximizing. So the first point that we want to plug in would be, let's just list all of our points that we have from that graph that I just did. 0, 0, 0, 7, 4, 3, and 2, 0. Okay? So 3 times 0, obviously if we don't use anything, plus 2 times 0 would just give us an output of 0. Okay? 3 times 0 plus 2 times 7 would give us 14. 3 times 4 plus 2 times 3 would give us 12 plus 6, which is 18. And 3 times 2 plus 2 times 0, which gives us an output of 6. So if I'm looking to maximize my, whatever I'm trying to maximize, they're not even specific in this one. Could be output, could be money, we don't really know. It's going to be when I have 4 of my input and 4 of the one that's on the x-axis and 3 of the whatever article is on the y-axis. I know this probably seems really overwhelming right now, and that's okay. It will make sense when we are doing it in class and then when you work on your project. Okay? So that's the core, and that's the end of your notes for Unit 6. Add a whole nother graph. So the first one it wants me to graph is y is greater than or equal to 3 halves x minus 3. So I'm going to go to negative 3, sorry about that, up 3 and over 2. And I would have to do that again to get within my limitations, because in a minute I'm going to have limitations there. So that's going to be my first constraint. It's going to be graphed as a straight line, and then it will be shaded everything on this side of the line, because it's everything greater than that. So you always go to your y-axis and decide whether it's above that point, greater than, or less than that point, lower than. Second constraint is y is less than or equal to negative x plus 7. So plus 7 is going to be way up here. Negative x will be going down 1 and over 1. That's also going to be a solid line. But this is going to be graphed everything less than that line. So far, can you see a range that's overlapping? So everything in this range is overlapping. But now we're going to have a couple of things that constrain it even more. So the next thing that constrains it has to be all x values greater than or equal to 0. So it has to be everything here where all of my x values are greater than or equal to 0, which is everything 0 and above. Then my last constraint is all the y's greater than or equal to 0, which is there. So really my only area that satisfies all those points is right in here. So let me trace over that with, let's see, let's go yellow. Okay, this is my solution set right in here. Okay, so now I need to figure out the points within that set that are going to be even possibilities of a maximum. So once you do that, you're going to now figure out the coordinates of all those. So here in the middle, so let's see what we've got here. Let's shrink this down a little bit. Okay, so this point up at the top, I've got, well, I know that was an intersection at 7, so that was 0, 7. Here down at the bottom, of course, if I don't sell anything, I've got 0, 0. Over here, well, this was at negative 3, and then I went up 3 over 2. So if I went up 3 and over 2, this should be at 2, 0. So really the only one I have to figure out is this line right here. Well, that is an intersection of my two original equations, which were y is greater than or equal to 3/2 x minus 3, and y is less than or equal to negative x plus 7. Here's a case where you're going to kind of ignore the inequalities for a minute. And if we pretended that they were just both equal signs, okay, we could actually, if we saw that as a system, we're trying to figure out the point where they cross right here. And this is what we've been doing. I need to find where that intersection point is between my negative x plus 7 line and my 3/2 x minus 3 line right here. So I'm going to treat this like a a system of equations. And I can set, since they're both equal to y, I can set this equal to this and solve. So I'm going to get 3/2 x minus 3 equals negative x plus 7. I'm going to bounce that 2 out of there because I don't want the fraction to deal with. And really, I only need my x coordinate, and then I can plug in and solve for y. Let's scoot all this up. So that gives me 3x minus 6 equals negative 2x plus 14. I'm going to add 2x here and add 6 there. So I get 5x equals 20. So my x equals 4. So let's put that over here. Then I need to plug back into one of my equations. I'm going to use the negative x plus 7 because that's pretty easy and it has no fraction in it. So y equals negative 4, because that's my x value, plus 7, and negative 4 plus 7 is 3. So that coordinate must be at 4, 3. And if I look at it logically, that coordinate looks like it could be at 4, 3, doesn't it? Go over 4 and up 3. That looks about right to me. So let's write that one in, 4, 3. So I want you to make a note of these 4 points, because we're going to evaluate our objective function for those 4 points. Okay, so